Good day! We are the Oceans 13 Mod 7 team, here to present our proposed solution to the Karagathon challenge. Oceans 13 Mod 7 has 6 members: Val Randolph Madrid, the team coordinator and lead; Rutherford Belleza, the Android developer; Ariel Doria, the web developer; Zenith Arnejo, the database and API developer; John O'Neill Jeronimo, the analytics developer; and finally, Dr. Asuncion de Guzman, fisheries expert and consultant from Gaia Resource and Environmental Consultancy Services. We designed our proposed solution to address 3 challenges faced by municipal fishing presented during the forum discussion on July 28, 2020. These are: limited personnel to cover vast municipal fishing grounds; limited budget allocation that hinder most LGUs from investing in technologies that can assist them in this task. When a fishing ground becomes poorly managed due to the reasons mentioned, decline in fish catch would soon follow. Like its sounds like superhero namesake, the BaTMon system is a technology that aims to foster cooperation among fishers, law enforcers, and local fisheries managers in maintaining a healthy municipal fishing ground. BaTMon aims to assist local law enforcement by providing tech that would allow fishers to monitor and track their boats when they go out to fish. The system uses readily available equipment such as phones and tablets to act as tracking devices, desktop computers that host database and web servers, and Wi-Fi routers and switches that would link all of this. This may function even without internet, though additional features might need internet. Through BaTMon, LGUs can invite researchers to view the data analytics, to do further research and make policy recommendations. The BaTMon system is comprised of 4 linked components. BaTMobile is an Android-based app installed and run on the fisher's mobile device before he heads out to fish. The app will function like the vessel monitoring systems or VMS found in bigger ships. This component tracks bangka movement and fishing locations where catches are recorded. BaTweb is the web app where the data from the BaTmobile gets projected, letting LGU authorities know the locations where fishers fish. This could also be used to determine if a fisher has complied and followed regulations, such as fishing ban in certain areas. BatDBase is the database for BaTMon. It records the data submitted by every BatMobile, so it can be viewed by BatWeb and BatCam. It is locally hosted on a computer and may need to be hosted on the cloud if it is to be integrated into BatCam. BatCam or Catch Analytics for mobile is an extension of the BatWeb and BatDBase. It was designed for mobile but can also be implemented as a feature of BatWeb. Once data is accumulated in BatDBase, BatCam can query the data and create map visualizations and analytics through charts that would convert the data into useful information. To further elaborate on these components, Ru will talk about BatMobile, Ariel will tell us about BatWeb, Zenith will describe the BatDBase, and O'Neill will share about the BatCam extension.
Just a quick rundown on what BatMobile's functionalities are. BatMobile makes use of Google location services, and these location services make use of all of the sensors available to the phone. And the data that is gathered from the Google location services would then be stored into a database while it's running in the background. This data will eventually be uploaded after every single session. So every single time that a fisherman goes out, there'll be a single session, and the session would end by the time he gets back. And all of the data that would be stored would be uploaded into a server for post processing.
For the easy monitoring of the municipal waters, BatWeb application was developed. It aims to provide a map visualization of when and where the fisher folks took their catching sessions. These data are gathered from the smartphone application BatMobile. The web application uses an open source mapping named OpenLayers and written in JavaScript with the help of Node.js, React.js, and Bootstrap packages. OpenLayer is responsible for creating a dynamic map where map tiles are being displayed. On the other hand, Node.js and React.js is responsible for making the user interface interactive, which efficiently update the right component when data changes, while Bootstrap makes a responsive design of the user interface. Because of the open source characteristics of the tools used, BatWeb app need not always to be connected with internet source, which means it's very affordable for the local government and authorities with low funds to this technology, and as well as it can be installed on computers in port with low to no internet signal. To communicate with the database, MongoDB, BatWeb interacts via the API endpoints such as find all, get certain both, get average speed. The data are sent via the JSON format and tokenized on the web for easy plotting of the information needed on the map. This information includes the MAC address, start and end time of fishing session, locations traveled using the latitude, longitude, heading, timestamp, speed, and average speed in kilometers per hour. Some of its information is displayed in pop-up window when certain points are being clicked.
One of the motivations for the BaTMon system is to provide support to local government units in their efforts to monitor activities in the municipal waters. To do that, the database was designed to work with the BaTMon system and to serve as a storage for data on fishing activities such as fishing effort and catch details. The database was designed based on the structure of the JSON file created and sent by the BAT mobile tracker. JSON file format was chosen since it is the de facto standard for exchanging data between web and mobile clients, as well as with various backend services. Furthermore, JSON uses human-readable text, so non-technical people can easily read the data just by looking at the JSON file. The JSON file is organized this way. A boat is identified using the MAC address of the mobile device of the fisherman. The boat identifier is coupled with the session list. One fishing effort is equivalent to one session. A session typically contains the information on the start time and end time, meaning the time the fisherman went out to the ocean and the time it returned back to the shore. The session list contains two lists. One is the record list, which contains the timestamp, latitude, and longitude locations of the banca, as well as its heading and speed. The other list is for the catch. A single catch contains the timestamp, latitude and longitude, and a related photo or proof of the catch. This information is stored in a local database. MongoDB was a database of choice for this application since it is scalable, meaning it can keep up with increasing amount of data, high performance in comparison to traditional databases, and lastly, it is open source and document-oriented. In order to interact with the database, Node.js REST API server using Mongoose ODM was created for the web backend. And lastly, for the front-end technology, React is used to make database requests and to receive response. The MongoDB Node.js React full-stack development approach is one of the most widely used approach. Thus, if ever this application gets deployed and utilized by the LGUs, training stakeholders and administrators wouldn't be a problem. As of the moment, only some important minimal functionalities were created. These are save. This function writes the contents of the JSON file to the database. Next, get certain boat. Given a boat MAC address, return all stored information regarding the boat. The third is find all. This function returns the list of all boats in the database. And lastly, get average speed. This returns the average speed of the boat as well as the average speed of the boat on each of its session. Many more functionalities can be added to process data on the presented database. For now, what is implemented is already sufficient to support boat tracking. That's it for BAT DBase.
I will now present to you the mobile app extension of this proposed project. Anyone can harness data, but to process it and be able to make informed decisions out of them is a whole new level. This task is what researchers commonly face and what this mobile application is trying to solve. Bangka Catch Analytics for Mobile, or BATCAM, tries to address the need for portable and efficient data analytics solutions based on the aggregated catch data stored in the database. It aims to help researchers through informative graphs and map visualizations made through free and open source libraries. The heat map feature of the mobile app, for example, uh, mirrors the catch location stored in the database. It can therefore show the areas with high fishing concentration, which is a helpful indicator needed in creating regulations and policies for fish catch sustainability. In this sample map, we have plotted fish catch locations from different municipal fishing boats, each with different colors to distinguish them from each other. Whenever an area shows a reddish color, fish catch locations tend to cluster, which could mean higher fish concentration related to spawning, among other things. Another useful feature of the mobile app is data analytics. The data analytics feature makes data comprehensible and easily understandable, both to fisheries experts and layman users. Computations and trends on catch volume, catch per unit effort, and species distribution can also be derived from the existing information in the database. This can help researchers in giving informed suggestions to policymakers and/or local government units.
As with all things tech, we have to acknowledge the limitations of the BaTMon system as well as its potential to be expanded and adapted. In terms of limitations, the system is not real-time. The data from a fisher can only be recorded into the database once the fisher has gone back to shore, not while he is still out there fishing. Battery life of mobile phones is also a big factor in the long run, but users can opt to invest in readily available battery life extenders such as power banks. In terms of potential, if fishers use the camera via the app to take photos of their catch, they can also use the camera to take photos of violators if they spot one. The image and its location data can serve as evidence helping local enforcers such as the Bantay Dagat. Moving forward, more functions can be added to the system through building up the API calls of BatDBase to enable more data analytics that would then be integrated into BatCam and extend the functionality of BatWeb. So that's BaTMon system in a nutshell. Our proposed solution that hopes to address the challenges of municipal fisheries. By purchasing affordable hardware and software and harnessing BaTMon's capabilities, LGUs can beef up law enforcement and engage with homegrown researchers for data-driven policy and development. I am Val Randolph Madrid on behalf of Oceans 13, Mod 7 from the Institute of Computer Science in UP Los Baños. This Karagathon was indeed a challenging and worthwhile endeavor. Thank you for the opportunity.